Hey guys, welcome to the machine learning tutorial series, and in this episode we're going to learn about R. So for those who haven't heard of R is a tool for statistical modeling and predictive analytics. So if you want to predict if a patient is going to get heart attack or not based on probably blood pressure and cholesterol, or if you want to predict if the share price is going to go up or down based on the market trend, then R is the go-to tool that you're looking for. There are many factors which make R arguably the most powerful tool for predictive analytics. First being that it is simple yet super powerful. In fact, you can build a simple statistical model using a single line of code in R. It has very few syntaxes and is super easy to learn. Secondly, it has large user base with tons of packages. Third, it is open source and free to use. In short, for statistical computing, R is the best. Before we get started, we will see how to install the essentials for this tutorial. For those who have installed R and RStudio, you can fast forward to the part where we get started with the actual tutorial. And for all others, please follow along. To install R, open a web browser and type download R. Now click on download R for Windows link and then click the download link again. Once downloaded, install the same. There are two options to install, the 32-bit version and the 64-bit version. My system architecture is of 64-bit and hence I installed the 64-bit version. But based on your system architecture, install the corresponding version. Once installed, you'll have an icon on your desktop or startup like this. Click on the same. So this is the R interface. This is an interactive interface and you can type a command, say 5 plus 4 and get the result in the next line. Well, this is not really a user-friendly interface in my opinion and becomes really hard to try out long lines of code. For the same, I'm going to use something called RStudio, which is far more user-friendly GUI. I'll talk about this interface later, but first you need to install it. And you can do the same by opening your Chrome and going to Google and typing download RStudio and click on the first link and download the free version. Once you download the same, on your startup, you'll have an icon like this. Click on the icon to open it. Now, this is the interface of RStudio. So you type the code over here, get the result over here. If your code generates any plots, then it is produced over here. And any R objects created during the execution of R scripts can be seen over here. In the scripts window, you can type the code, say 5 plus 4, 3 plus 1, 3 plus 6. Now you can execute any line of code by first selecting the line and then clicking on the run button to execute. You would get the output in the output window below. Instead of using the run icon, you can also use the keyboard shortcut Ctrl plus Enter in Windows. We are going to be using a dataset called Iris, which is available in my GitHub repository. It is an open source dataset available in UCI machine learning repository. For the sake of convenience, I've placed it over here. This dataset is about a flower called Iris. You can find that it has 5 columns: sepal length, sepal width, petal width, and species. There are 3 species of iris: setosa, versicolor, and virginica. This dataset contains 150 flower, 50 in each species. Let me click on this raw button, which shows the data in the raw CSV format where each column is separated by comma. To import this data, we use this link. Now let's get started with our tutorial. I'll go back to RStudio. This tutorial script is this. All the code shown in this tutorial is available in my GitHub repository, the link for which is available in the description section. To read a CSV file in R, I can use read.csv command. So read.csv, then location of the file, in this case the GitHub link that we saw previously, and then you have to mention if the first line of the data is a header or not. If you go back to GitHub and look at the data, the first line is the header, and hence in the read.csv function of my script, I'm mentioning header equal to true. On executing this line, you can see the entire table in the output window. This just prints the data, but I need to perform some operations on data, and hence I'll store it in a variable called df1. Once this line is executed, you could see that df1 object is immediately seen in the right tab. In fact, all objects created will be seen over here. You can assign data to a variable using equal to operator or an assignment operator like this or like this. All the above 3 lines perform the same operation of assigning the data to the df1 variable. In my code, you can find lines starting from hash. So such pieces of code is just to make the code more understandable and doesn't serve any purpose. These are called comments, and if you select that particular line of code and execute, you can find that nothing happens. Previously, we imported data into a variable, and now we can view the contents of the imported data by using the view command like this. Now, in the new window, you can see the 5 columns and 150 rows in the total. Now, a table is called data frame in R. Now, I don't want to see all the rows and all the columns of this dataset. I want to see only a subset of rows and columns and probably perform some operations on the same. So to select subset of rows and columns, we first use name of the data frame, in our case df1, followed by a square bracket, and the square bracket takes two parameters as input. The first input is used to select the rows, and the second input is used to select the columns. Now, if I want to print all rows of sepal length column, then we mention sepal length in the columns part. Now, the first part before the comma in the square braces is used to select subset of rows. And since we are not filtering based on rows, we leave this part empty. When we execute this line, only the sepal length column data is printed in the output below. Similarly, if I want to print sepal length and species column, then I mention them in the columns section. A small note over here is that when more than one names are to be used, then we combine them using this C function, which stands for concatenate. When this line is executed, we see only the selected columns in the result window. Instead of using the column names to select the columns, we can also use column indexes, where index starts from 1 in R. So this line of code does the same operation as that of the above, that is selecting sepal length and species column. Here sepal length is the first column and species is the fifth column, and so we have C of 1, 5. Apart from using names and indexes, we can also use true or false. So there are 5 columns in our dataset and there are 5 true or false values, and all the columns with corresponding true is selected. In our case, true is therefore the first and fifth column, and hence only those two columns are selected. You might wonder why true or false is even there for selection, but you will understand how powerful this is soon in the next example. So same is the case with selecting rows as well. You can use index like this. When this line is executed, it prints the first 5 rows of all the columns. Instead of writing C of 1, 2, 3, 4, 5, you can simply use 1:5, which is equivalent to C of 1, 2, 3, 4, 5. And for the record, this is the third syntax I'm talking about, which is using colon to generate numbers. So to select rows, you can use index, you can use names if each row has a name. By default, row numbers are the row names, and hence the row index and row names are the same by default. Later we will see how we can assign names to rows and select the same. And also you can use true or false values. Let's see an example of the same. We know what this portion of the code does, right? It simply selects the species column. So this entire expression returns true or false for each row, where it is true for all rows whose species is setosa and false otherwise. If you look at the data, it can be observed that the first 50 rows species is setosa, and hence it's true for the first 50 rows and false for the rest. Now I'll place this expression inside the select statement for rows like this. Now this entire expression will select all rows whose species is setosa. Now on executing this line, the result can be verified from the result as well. How powerful can this be? We have just a single condition in the above example, but we can place multiple conditions using the AND operator like this. For example, species is equal to setosa and sepal length greater than or equal to 5.5. And from the result, we can see that there are around 5 rows which match this condition. Now, if you are selecting a single column, then you can use this syntax as well. That is, data frame name followed by $symbol and then the name of the column. For the record, this is the fourth syntax that we are learning. We can subset the rows and columns, and in this example, we are selecting the first 5 rows of the column species. Some commonly used functions are nrow and length. You can get the number of rows in a data frame using the nrow function. And on executing nrow of df1, it returns 150, which tells that there are 150 rows. So the below line prints all rows from the 10th row till the last row of the dataset. Length function, on the other hand, gives the number of columns in the data frame. So the below command prints all row for the column 3, 4, and 5. Also, if the index is negative, then it simply excludes that particular element. For example, on executing this line of code, only the 5th column is excluded. And on executing this line of code, only the first row is excluded. To recap what we have discussed so far, we can subset a data frame using the below simple syntax: data frame name followed by square braces, which takes two parameters. First is to select the rows and second is to select the columns. And we can select using three different methods, that is, using the names, then using index, and using Boolean operators as well. In all the examples seen so far, we have used this concatenate operator on text, numbers, and Boolean true or false values. We have also used colon operator. On executing these lines, it can be observed that each set of command is a collection of numbers or text, or it's a collection of true or false Boolean data. A collection of similar data types is called a vector in R. So the first one is a vector of numbers, the second is a vector of characters, and the third is a vector of Boolean data. Let's open df1 data frame, and it should be noticed that a data frame is a collection of vectors where each column is a vector. In our case, the first column is a numeric vector, second column is a numeric vector, so is the third and fourth column. The fifth column is a character vector. We can also validate the same by executing this line of code. When we select a single column of a data frame, it can be observed that the data is returned as a vector and not as a table data frame. We can check if an object is a vector or not using this is.vector function. So on executing is.vector of df1 $species, it returns true, which suggests that this particular df1 $species is a vector. Filtering a vector is similar to that of a data frame. We start with the name of the vector followed by square braces, and inside the square braces we can select elements of vector using names or index or true or false Boolean values. So I create a vector called vector1 which contains numbers from 15 to 25. I'll print the same. Now to access the first 5 elements of the vector, I can simply give name of the vector, here vector1, followed by square braces, and then the elements that I want to select. And in this case, the first 5 elements. On executing it, we can see that the first 5 elements of the vector is printed. If the vector element has names, then we can select the vectors using names. And also we can use Boolean true or false values. In this example, we are selecting all vector elements whose value is greater than 20. On executing the same, we can find only values from 21 to 25, even though the vector contains values from 15 to 25. Also, if we store a single number inside a variable like 5 over here, it is stored as a vector with just one single element. Is.vector function can be used to check the same, and on executing it, it returns true, which suggests that this single number is actually a vector. You can concatenate any number of vectors. For example, in this example, we are combining values of data1 variable with numbers of 1 to 5 and vector1 and sepal length column of the df1 data frame. And on executing the same, we can find all the concatenated values. It has to be remembered that vector is a collection of similar data. Each element of the vector should be of the same type. Now, if we try to create a vector with number and text data, then it can be observed that all elements are converted into text and stored. If something is enclosed by quotes, then it's a text data. So R automatically converts the elements into a common type, in this case a character. We can find the number of elements a vector has using the length function. Alright, we have seen data frame and vector. A data frame is a table and a vector is a collection of similar data. A matrix is exactly same as that of a data frame, except that it can store only numeric data. This makes sense because you can perform matrix related operations like determinant of a matrix only on a numeric data. One of the ways to create a matrix is to use the matrix function. This line of code creates a matrix of 3 columns with elements 1 to 9. The same can be seen in the output. Let me store the matrix to a variable mat1. T function can be used to find transpose of a matrix. Det function can be used to find the determinant of a matrix. We can get the column and row names of a data frame or matrix using the call names and row.names functions. The same can be observed in the output on execution. For matrices, the row and column names is null because we haven't assigned any. We can assign using equal to operator. So the below two lines assign row and column names to the matrix. Once the row and column names are assigned, we can select the rows and columns by their names. So this line of code selects row 1 of column A and C of the matrix mat1. Similarly, you can assign names to vectors using the names function. So this line of code assigns the name to each element of vector 1. On executing, the below lines shows the contents of the vector along with its header. Now we can select any particular element of the vector using the name, like element C. You can find mean of elements of a vector using mean function. Similarly, you can find sum, median on the elements of vector using the corresponding functions. Summary function is quite interesting, which gives minimum value, maximum value, first, second and third quartile and the mean. Summary function can be used on data frames as well. So we have tons of functions like the one we saw to perform various statistical operations. But what if we want to perform some custom operations? Then we create our own functions, and it's pretty simple to do as well. Let's create a simple function which when called prints hello. To create a function, we first give the name of the function, say fun1, followed by equal to operator, and then we use the function keyword, and then inside the round braces we mention the parameters that it takes as input. This function doesn't take any input and hence it is empty. And inside the curly braces, you write all the code that you want to execute when the function is called. I want this function to print just hello, and hence I've written only one line, that is print hello. Now I'll select the entire function and execute it. Immediately on the right window, you could see that fun function has been created. Now I can call the function using the name followed by the round braces. Hello is printed in the result. Now let's make it a bit more complicated. I want to create a function which takes two inputs. First input should be a matrix and second input should be a vector. And the function should add up the determinant of the matrix and mean of the vector passed as input. So for the same, I have created a function called fun2 which takes two parameters, m1 and v1. And in the body of the function, I add up the determinant of the matrix with mean of the vector and then return the result. When I call the function, I need to pass the parameters for the function. And the first parameter should be a matrix and hence I'm passing mat1. And the second argument should be a vector and hence I'm passing vector1. On executing the same, we can find the result below. If you look into the object window, you could notice that the object used inside a function like r1 is not present, which suggests that objects created inside a function are deleted once it's executed. It is to be noted that the moment the function executes return statement, it will come out of the function. So you can return only a single object from a function. Now I want to return not just the result of the calculation, but the matrix and vector with which I did the calculation. But we already discussed that a function can return just a single object. For the same, we have something called list. A list is an R object which can store multiple objects. For example, the first element of the list can be a data frame, second element of the list can be a matrix, the third element of the list can be a vector. Now let's try it out. You can create a list using the list function. So this line of code creates an empty list called L1. Now I'll store the contents of the data frame df1 inside the first element of the list. Remember that we are using a double square braces to reference elements of the list. We will store vector1 as the second element of the list and we'll store matrix that we created mat1 as the third element of the list. Once you have stored data inside a list, you can view contents of a particular list element using the name of the list along with the index of the element inside the double square braces. So the syntax to access elements of a list is name of the list, in our case L1, followed by double square braces, and then you mention the element that you want to access. You can also access list elements using their names. We will see how we can assign names to elements of the list. You can use the names function to access the names of a list. Since we haven't assigned any names, we are returned with a null. In the next line, we will assign names to the elements of the list. Once the names are assigned, you can call a particular element using its name, say L1 and double square braces, and within quotes, you give the name of the element, here matrix, returns the matrix inside the list. Now we can use the list to return multiple objects from a function. The below function adds the determinant of a matrix with the mean of a vector, and then it stores the matrix vector and result of the calculation inside a list called R2, and then it returns the list R2. Now when we call the function, we can observe that 3 elements are returned. We can store the result of the function inside a variable, in this case result1. Now result1 is a list which contains the returned list of the function, and you can access any element, say the second element, using the corresponding index. Now we will look into an important function called apply. It is super easy and powerful. Previously, we saw a function called mean which finds the mean of a vector. But what if we want to perform the same operation on columns of a data frame? Now if I execute this line of code, I'll get the mean of the first 4 columns of the df1 data frame. So how does this function work? It takes 3 main parameters. First is the data frame on which you want to perform the operation. In our case, I want to find the mean of first 4 columns only, and hence I've selected only the first 4 columns of df1 data frame. The second parameter is used to tell if you want to perform the operation on row or column. In this case, I want to find the mean of first 4 columns, and columns are represented using number 2. If you give 1 over here instead of 2, then it calculates for rows. And the third argument is the function that you want to perform, in this case mean. Now you can try replacing 1 with 2 and see that you will end up getting the sum of each and every row. There are 150 numbers in the result because there are 150 rows in the dataset, and there is a sum for each and every row. Apply function can be used with matrices as well in the same way. Now what if I want to perform some custom operation on column instead of performing simple mean or sum? So in the next example, we will calculate mean divided by median for each and every column. Here you can observe that in place of function, you have defined your own custom function. So on executing the same, you get the result. Similar to apply, there is something called lapply, which is used to perform same operation on elements of a list. First, let me create a list which contains 3 vectors as shown below. Now my objective is to find the mean of each and every vector element of this list. For the same, the syntax is lapply, and then the first parameter is the list that you want to perform the operation on, and the second parameter is the operation that you want to perform. From the result, you can see that mean of each and every vector element of the list is calculated. lapply gives the result again in the form of a list. There is another function called sapply, which gives the same output as that of lapply, except that sapply tries to simplify the result. In this case, the result is simplified to a vector, which is easier to handle. Now say I want to perform the mean of sepal length of each and every species. You can do that using tapply function, which is used to group by and aggregate. Before I talk about this function, let me first execute it. The output shown below is the mean of sepal length for each species. So tapply takes 3 parameters. The first one is the column on which I want to perform the aggregation. The second is the column using which I want to group, in our case species, and the third is the aggregate function that I want to implement, in our case mean. Instead of mean, you can implement your own custom user-defined function. We saw how we can aggregate sepal length for each species. But what if I want to aggregate multiple columns based on species? For such requirements, we can use aggregate function. So the below line of code finds the mean of first 4 columns of df1 data frame for each species. Aggregate function takes 3 parameters. The first is the data frame whose columns need to be aggregated. The second is the list of columns based on which you want to group. The list function creates a list using the elements passed as input. You have used this function to create a list, but previously we did not pass any argument to this function and hence it created an empty list before. But now, in this case, it creates a list with one element, which is the vector containing species column data. The third argument to aggregate function is the aggregate operation, in our case, mean. Now I want to find the sum of elements of a vector if a particular variable is a vector. Else, I want to print not a vector. For the same, I can make use of an if-else statement. So this syntax of if-else statement is if, and then within round braces, you give the condition that you want to check. In our case, the condition is to check if the object is a vector or not. And then following that, inside the curly braces, you give all the commands that you want to execute if the condition is met. In this case, I want to return the sum of elements of the vector if the condition is met. The set of commands to be executed when the condition is not met is mentioned inside the else statement. In this case, simply print not a vector. So if-else statement can be used to perform a certain operation if some condition is met and perform some other operation if the condition is not met. The function is created when it is executed. Now first we call the function using a vector and we find the sum of elements of the vector in the output. Next we call the function using a data frame and we see not a vector printed in the output. Now before I talk about the next set of commands, let me first execute it. From the output you can see that hello has been printed like 10 times. So if you want to perform some operation certain number of times, then you can use something called loops. While is one of the loop function and it executes all commands within its body as long as the condition is true. In this case, as long as var1 is greater than 0. So it starts by checking the condition first, and if the condition is met, then it executes everything inside the body and then it checks the condition again and it repeats the process. So I initialize var1 to 10 before the start of the loop, and inside the body I print hello along with the value of var1. Paste function is simply used to join hello text with var1 value for printing purpose and nothing more. I also subtract 1 from the var1. So after 10 iterations, the value of var1 will be 0 and then the condition becomes false and stops the execution. Below is another example of while loop. I'm creating a list with 4 elements where the first element is a data frame which contains iris data. Second element is a vector which we created previously. Third element is a vector which contains sepal length column data. And fourth element is a vector which contains petal length column data. So this loop iterates through the elements of the list and prints the sum of elements of the vector alone. Another kind of loop in R is for loop. Let me first execute that loop to see the output. In the for loop, this variable var1 iterates through the elements of the object mentioned over here. So during the first iteration, it will take the first element of this object, in this case 1, and then execute everything inside the body of the loop, and then it takes the second element of the object and executes the body of the loop, and so on. And that's why you see hello 1 till hello 10. It is to be noted that var1 is a variable name and you can use any name of your convenience. Let's look at another example of for loop. Let's perform the same operation which we performed using while loop, that is, iterate through the elements of a list L2 and print the sum of vector elements alone. So in for loop, var1 vector takes one element of list L2 at a time and checks if it's a vector, and if it is, then it finds the mean of it. Let's look at some additional data frame operations. It's pretty much what we have already seen. This line of code creates a new column called col1 in data frame df1, whose value is sepal length value plus 10. The next line of code creates a new column called col2 in df1 data frame, whose value is sepal length value plus the petal length value. The next line of code sets sepal length value to 0 for all rows whose species is setosa. Let's view the result to confirm if we did what we intended to do. And yes, it is correct. rbind function is used to add rows from two or more data frames, like union all function in SQL. The below example combines the rows of df1 with itself. Previously, df1 had 150 rows, but now on viewing the result, we can see that it has 300 rows. Just like rbind binds rows of data frame, cbind on the other hand binds the columns. So the below example binds the columns of df1 with itself. Head function just prints the first 6 lines of the result, and from the result we can see that each column is present twice due to cbind function. Now previously we used read.csv function to read data from a CSV file on GitHub. We also used header equal to true parameter to mention that the first line of the dataset is a header. But how do we know what are all the parameters read.csv function takes as input? So in R, we can know parameters of a function using this question mark operator. So question mark followed by name of the function gives the manual of that function. So on executing that line, we can see the manual for read.csv function. So you can scroll down to see that it takes quite a lot of parameters. Similarly, the same is the case for other functions as well. For example, mean function. For those who work with SQL, you can perform SQL joins using merge function. For those who don't know about SQL, don't bother about this command. But on a high level, it is used to join two tables based on a column. Next, let's see how we can plot data. Let me execute this line of code and you can see that you get a straight line. For x is equal to 1, y equal to 1, for x is equal to 2, y equal to 2, and so on. So you can perform simple scatter and line plots using this plot command. Here the first argument is the vector of x values and the second parameter is the corresponding y values. Make sure the x and y values are of the same length, else it will throw an error like the next command, where the number of y values is 12 for 10 x values. The next line of code plots sepal length against petal length. Table function is used to find the count of occurrence of each and every category in a vector. From the result, we can see that there are 50 occurrences of each species of the iris dataset. Bar plot can plot the result, thereby helping me to visualize. Now I'll remove all rows whose species is setosa. Now if I create a bar plot, I can see that I don't have any bar corresponding to setosa. It looks as if there is only two species. However, my requirement is that it should at least show me 0 for setosa. How can we achieve this? This introduces us to a very important concept called factors in R. Let me first re-import the data again. I can check the structure of the data frame using a function called str. And I can see that the type of species column is CHR, which stands for character. Now I'll convert this column into something called factor using this function as.factor. So a factor is a data type to store data which has categories. In our case, species is a categorical column. Now if I check the structure again, I can see that the column has 3 categories: setosa, versicolor, and virginica. Now I'll perform the same operation, that is, remove the setosa species and then plot the same. From the plot, we can see that for setosa it is 0. This is because by making it a factor, R will remember all the categories available and give the result accordingly. It is very important to make all category columns as factors. There are some additional functions to convert between the data types. For example, as.factor, as.numeric, as.character, and so on. For example, you cannot add a text number 5 with a numeric number 5. It will throw an error. You'll have to first convert the text to numeric before you can perform the operation. Instead of using as.factor, you can also set strings as factor parameter in read.csv to true so that all string columns are imported as factors. Once you execute this line of code, you can check the structure of the imported dataset to find that species is imported as a factor. We can perform super amazing operations by importing packages written by other people. For example, open Chrome and type plotly R and then click on the first link. Plotly is an R package to create amazing charts and graphs. And all the amazing plots you see over here can be created using just one line of code. Let me select scatter plot over here. I'm assuming that it looks a lot fancier than the plot that we have produced using the simple plot function. I like this plot. And so I'll copy this line of code to create that plot, go back to RStudio and paste the line of code. Before we execute it, we need to install plotly library first, which can be done using install.packages function. Once installed, you can load the package, and to load a package, we use library function. Good that they are working with iris dataset. I'll just change iris to df1, but leaving it at iris doesn't make any difference. Now I'll execute this code. It will take some time to execute, and a window in Chrome would open up with the plot. All right, this is the plot, and it looks a lot fancier, and it gives tooltip as well. I can also zoom into a portion of the plot to see the details. Nice. So now we'll look into another nice package called dplyr with an example. Assume that now I want to perform these operations. That is, first find the square root of numbers from 1 to 5, then round the square roots to whole numbers, and then find the sum of the rounded numbers. That's what I have done below. Sqrt function gives the square root, round function rounds the numbers, and sum function calculates the sum. But this is so difficult to type and read. What will happen if I have like 20 to 30 such operations, where each operation is dependent on the result of the previous operation? It will become too confusing to type and read. This can be sorted out by one of the features of dplyr package. Let's see how this can be done. First things first, install dplyr package. Once installed, load the same. Now dplyr has this interesting pipe operator. It is used to pipe the output of one operation as input to the other. The command that I execute above can be simplified to this line of code. First, numbers 1 to 5 is given as input to square root function, the result of which is given as input to the round function, and the result of which is in turn given as input to the sum function. Pretty cool, isn't it? There are tons of packages like the one we discussed to make R super powerful. To get a list of all the packages in R, open up your web browser and type R packages in Google. Click on CRAN packages by name. And this is the list of all the packages that are available for R. Alright, R masters, we reached the end of this tutorial. The code discussed so far is available in my GitHub repository. I'll also place some practice questions in my GitHub repository to validate your understanding. Hope you enjoyed it, and thanks for watching.